Howdy, eighth grade. I am very, very excited for today's lesson because we're finally getting a real lesson on the Pythagorean theorem, and it is about darn time. So, uh, I know we haven't used this as much as we could have, but I've kind of been saving it for this lesson, which I'm very, very excited for. Uh, so we're going to look a little bit at the area of this square to start with, and we're going to see what happens. So we know that the area of a square, area equals base times height, but this time I'm already using b, so I'm going to call that width times height just so we don't get any confusion. So area is width times height. And looking at my square I have here, that would be the same as b plus a for my width, b right here, a right here. That's my width, and my height would be b plus a. So looking at the square, it's probably a little hard to tell where I'm going with this. So what happened was I took 4 of this triangle right here. I took 4 of these, and I put them all kind of together in a weird way down below. And the nice thing about right triangles is that I know that this is also a right angle here. These are right angles, which I already had. And these are all right angles on the inside, which makes my life really easy. So I just took 4 of these, and I kind of rotated them in. So this point ended up down here, and this went here, and that kind of got the triangle where it needed to go. Let me make sure I can erase that. There we go. So I've got 4 of these triangles together, and I know it's kind of weird right now, but hold with me, we'll get there. I know that the area has to be the width times the height, which is b plus a times b plus a. We just looked at what these kinds of things give us when we FOIL them. So this should be b squared plus 2ab plus a squared is going to be the area. So my area equals b squared plus 2ab plus a squared. But that's not the only way to find the area of the square. So we're going to use a little bit of a different method. So what I want to start with is I'm actually going to find the area of all 4 of these triangles, 1, 2, 3, 4. And I'm also going to find the area of the square, which I'm going to call 5. And if I add all those up, I should get the total area of my square here. So if I have, let's see here, the area of one of these triangles, I should be able to just multiply it by 4 and have the area of all 4. So let's start with that. If I've got a triangle here that is a tall and b long, I find the area of a triangle with 1/2 AB would be the area of that triangle right there. And then I multiply that by 4, so times 4 equals 2AB. So my 4 triangles altogether give me 2AB, and I also have to add the area of this square here, plus, and the square is c by c, so my width times height would be c times c, which would be c squared. And if I bring that down below, I can now say that that has to be equal to the other way I found my area. So area has to be b squared plus 2ab plus a squared, but it also has to be 2ab, which is the area of my triangles there, plus c squared, which is the area of the square on the inside. So looking at this, it's a bit of a mess, but we think we might be able to clear up this formula a little bit. I'm going to take this a out of the way just so we can play with these numbers a little better. And what I'm going to do is I'm going to subtract 2ab from both sides, because I've got that on both sides, so subtracting is going to make my life a lot easier. Now I have b squared plus a squared equals c squared. And this right here is the Pythagorean theorem. Not only is it the Pythagorean theorem, it's also how the Pythagorean theorem was found. So this is the proof for it. When y'all go into geometry, either next year or the year after, y'all do a lot of proofs. They're a bunch of fun. This one's one of my favorites just because I think it's very kind of intuitive. Looking at the area of this thing, we can find it 2 ways, and then we set them equal to each other. And ta-da, we have the Pythagorean theorem, which is one of the greatest theorems ever discovered in math. So that right there is something that we're going to have to use. So let's keep going here. if I have a couple problems, we're just going to start looking at examples. We want to make sure we know that a squared plus b squared is c squared. And for us, c always has to be the hypotenuse or the long side. So c is the long side. So if I start off with a triangle that have lengths 6, 8, and c, I know that c is my long side here. It's opposite the right angle. So I can just start plugging things in. And 6 right here would be my a, so I'd have 36 after 6 squared plus 8 squared, which is going to be 64 equals c squared. So I started with a squared plus b squared equals c squared. Plugged in 6 for a, got 36. 8 for b, got 64 equals c squared. 36 plus 64 is 100 equals c squared. So I have to ask myself, what times itself gives me 100? And hopefully we're all thinking 10. So c equals 10. Let's look at a different one real quick. So if I have a triangle, this one's going to be a little bit different, with a right angle up here, and my lengths I know are 4 and 7. We'll call this G. So I know that I'm going to start with a squared plus b squared equals c squared. I also know that my long side has to be c. So 7 is my long side. So I get a squared plus b squared equals 7 squared, which is 49. I also see this 4 here, which has to be one of my two sides, and my g, which has to be the other one. So I'm going to replace a with g and b with 4 equals 49. And now with a little bit of simplification, I find that g squared has to equal 33. So if g squared equals 33, I can say that g equals the square root of 33. I'm not really sure what that is. You can't simplify it. If you do a factor tree, you get 11 and 3, which doesn't really help you at all. So g is just the square root of 33, and that is perfectly okay. So the other thing you can do with this is to figure out if something is a right angle, or is a right triangle. Is it a right triangle? And the answer is depends. Does it work with the Pythagorean theorem? So if my Pythagorean theorem works, Pythag theorem works, then yes it is. There's no not right triangles that can work with the Pythagorean theorem, which is really nice. So we're going to start with side length C here in this triangle. Sorry, y'all can't see that. Let me get a drawing y'all can see. So if I have the sides 9, 40, and 41, there we go. My question is this a right triangle? So there's only one way to find out. That's to plug it all in. 9 squared plus 40 squared equals 41 squared. If this is true, it is a right triangle. If this is not true, it's not. So we'll do this real quick. 9 squared would be 81 plus 40 squared, which would be 1600, equals 41 squared, which is 1681. So if this is true, I should get 1681 equals 1681, which is true, so it is a right triangle. Awesome. Let's look at one more case where this doesn't turn out to be true. And we will look at 8, 10, and 12 for the sides of my triangles. So I want to draw that. Just draw a right triangle. I know my long side would be opposite the right angle. I have an 8 and a 10, and I can see if this works. So I should get 8 squared plus 10 squared equals 12 squared. I know that 8 squared is 64 plus 100 equals 144. So that would tell me that 164 equals 144, which it does not. So this is not right. It's some other kind of triangle. So that's pretty much what all these problems are going to look like. In any case, I'm very excited about the Pythagorean theorem. Thank you guys for bearing with me through my proof at the beginning of the video. I think it's kind of fun. And I will see y'all in class tomorrow. Have a delightful day.